Okay. So, let's see here. Now we're going to be graphing these things by hand, or sketching the graph, of course. Okay. And again, just like we did with evaluating trig ratios, we're going to start looking at just sine and cosine, because those two graphs are kind of like fundamental then to help us figure out all the rest. Okay, everything else. I guess tangent kind of, we'll need to look at that one as a separate entity too. So really sine, cosine, and tangent. Once we know those, then we'll kind of have a good understanding of what their reciprocal trig functions will look like there. Okay, so that being said here, let's actually take out our graphing calculators, and we're going to graph sine of x on our graphing calculator to kind of get an idea of what it looks like. Okay, just to see here. Make sure your mode, by the way, is set to radians, please. Please make sure your mode is set to radians. Okay, so we'll do sine. Oops. So again, make sure your mode is set to radians, and then in your y equals, just type in the y equals the sine of x there. Ooh, glare. There we go. Okay, something just like that. Okay. So if you hit graph, again, make sure your mode, you're in the mode is radians. You'll see this nice kind of wave there, right? Nice kind of wave. All right. So it looks like then, how could we describe the domain of sine? Maybe. What do you think the domain of sine would be if we're going to describe that? Just looking at what we've got there. What's the domain here? What does it look like the domain might be? Yeah, negative infinity to positive infinity. Exactly right. Okay. Now, we've been doing so much with that unit circle, and we've been doing so much of the unit circle only between 0 and 2 pi, and we've been doing so much of that unit circle only between 0 and 2 pi, but also only certain angles, right, in between 0 and 2 pi. You know, for example, right now, if I was like, what is the sine of 2 pi over 9, we would have no idea unless we had our calculator, right? Because we don't know how to evaluate that. However, we can find the sine of 2 pi over 9, right? In fact, there's no number that when you take the sine of that number, you get an error or anything like that. So you can do like, you know, sine of 3 if you wanted to. Okay, 3 is not like a normal radian measure we might see, but you could say sine of 3 radians and get an answer here. Okay, especially using your calculator. And so the idea is that there's no domain restrictions, right? The sine is never undefined, so we can just plug in whatever x value we want, and we're going to get some sort of y value. So the domain is negative infinity to infinity. So is the range also negative infinity to infinity? Is it all real numbers? Yeah, clearly not, right? Or at least we can see in this little chunk of the graph, it's not the case. And in fact, it won't be the case. What is the range for sine? Say what? Negative 1 to 1. Okay, yes. And then should we include those negative 1s and positive 1s? Do we actually get to negative 1 and positive 1? Yes, I think. Or is there anything when we take the sine of it that we get a positive 1, or is there anything when we take the sine of it that we get a negative 1? Is that the case? Is there a sine of something that gives us a positive 1 as an answer? Yeah, what is it? Sine of pi over 2, right? Pi over 2. Sine of pi over 2 is one of them. Okay, that will give you a positive 1. And then sine of 3 pi over 2 will give you the negative 1. So certainly we do actually get to those negative 1 and positive 1 y values. Okay, we do. Okay, and in fact, later we'll be asking that kind of question where I'm not going to say sine of pi over 2 equals what. I'll say sine of what equals 1, you have to come up with like the different answers there that different values there that would answer that question. So it's kind of like the backwards, okay, inverse really is what it is. Okay. So there's kind of some basic information there about the sine graph. Okay. So it looks like it repeats itself, right? It's a wave. It's going to keep going forever and ever, that nice little wave behavior there. Okay, and so let's actually graph this. And since it repeats, right, okay, that repetition, all right, every time it repeats itself, or the length, I guess, or whatever, the repeated part, that's called a period, right? Okay, so it starts and stops and then repeats, and then repeats, and then repeats. Okay, so the period of the sine graph there. So let's graph the sine over 2 full periods here. So I'm going to start my graph like so. Okay, I'm actually going to take up like the most of my paper here. Let's see if I can get it to fit. Okay, yeah. Alright. Now a unit circle starts at 0 and goes around and repeats itself back at 2 pi. And so in fact that's what's going to happen here with sine. Our period for just plain old normal sine starts at 0 and it goes to 2 pi. And then after 2 pi it'll just repeat itself because we're now kind of going back into the part of the unit circle we've already traversed or gone through. And so I'm going to draw 2 full periods here. So and so what I'm going to do is I'm going to kind of split this in half somewhat here. I'll say let's go this far is 2 pi. And so then I'll kind of double that length out and say this far then would be, well, here to here is 2 pi. If I double that out, it's now going to be 4 pi, right? I'm going out another 2 pi in length. Okay. And then I'll find some other points here. I'm going to find like the halfway point pi and the halfway point here. Actually, I'll hold off on that. Let's just focus on that first period and then we'll get the rest of it. So we'll focus on from 0 to 2 pi here. Okay, and I'm going to do the half of the halves as well. So halfway between 0 and pi is pi over 2. All right, halfway between 0 and pi is pi over 2. And then halfway between pi and 2 pi, what's that going to be? 3 pi over 2. Yeah, 3 pi over 2. That's right. Okay, again, if you think about the unit circle, right? Okay. So 0 to pi, right? Halfway is pi over 2, and then halfway between pi and 2 pi, well, it's that 3 pi over 2, right? To continue around there. So there's the halfway point right there, 2 pi over 2. Okay. Then, of course, we have like way more than that as well. But let me go ahead and graph. So I'll put 1 there and like -1 right here. Okay. Because that's our range for just plain old sine here. We're just graphing sine. Okay. So our highest value we know is going to be 1. Our lowest value is going to be -1. All right. So let's just start here with 0. Okay. So what is the sine of 0? Sine of 0 is what? So there's 0, right? On the unit circle there. What's the y coordinate at this point? Sine of 0 is 0. So we have the point 0, 0. Okay, bless you. Start us out there. Okay. Now I am going to do these. It's going to be like I'm going to squeeze these in here. I'm going to squeeze in the pi over 6. I'm going to squeeze in the pi over 4. Just for this one, not for all of them though. I'm going to squeeze in the pi over 3 as well. Okay. So what is sine of pi over 6? What's sine of pi over 6? Like right there, right? What's that? 1/2, right? So let's see, about halfway up. We'll be right there, we'll say. Okay. What's the sine of pi over 4? Square root of 2 over 2. So let's see here. Square root of 2 divided by 2 as a decimal is approximately 0.71, we'll say. So we need to go a little bit higher than the 0.5 there, 0.7. I don't know, we'll say it's like right here maybe or something like that. Okay. And then pi over 3, what's the sine of pi over 3? Root 3 over 2, so that's like 0.86, so almost 0.9. Almost 0.9, so again, just a little bit higher there, we'll say. 0.86. And then what's the sine of pi over 2? Sine of pi over 2, yeah, it's 1. 1, right? So sine of pi over 2, 1. Alright, so we kind of connect these dots here. You can see, okay, that top part of our wave kind of forming there. Okay, and because, you know, of the symmetry here, right, so the next angle here will be 2 pi over 3, and then 3 pi over 4, and then 5 pi over 6, and those will just kind of continue to go down there, and so we can just, you know, see that it's going to continue the wave there. So let's just go ahead and evaluate. What's the sine of pi going to be? Sine of pi is what? 0, so we have to put a point there. Right, and we can just kind of like, oh, okay, it's going to go back down like that. Okay, what's the sine of 3 pi over 2? What's the sine of 3 pi over 2? Here's 3 pi over 2. What's the y coordinate on this point on the unit circle? -1. Yep, so 3 pi over 2 is going to be, sine of 3 pi over 2 is -1. And again, with those, you know, corresponding, you know, angles in between, so like 7 pi over 6, 5 pi over 4, 4 pi over 3. Okay, it's going to bring us down here like this. Okay. And then what's the sine of 2 pi? 0. Okay. And there it is. There's one full period of sine, because at this point now we're going to repeat ourselves. That's one full period of sine from 0 to 2 pi. Okay. So we can say here the period, maybe I'll throw this in addition here, it's from 0, okay, so one full period of sine goes from 0 to 2 pi. Okay, and I'm not including the 2 pi because technically 0 is already that position there, but you get the idea. That's one full period right there, and then it just repeats. Okay. And so then here we've got, we're now going to fit one full period between 2 pi and 4 pi. So you can imagine we're just going to take this chunk, and it's just going to be like repeated right there between 2 pi and 4 pi. Instead of starting at 0 and going to 2 pi, we're going to start at 2 pi, go to 4 pi, but it'll be the same thing there. Okay. So now let's do kind of a similar thing, right? Before, when we did 0 to 2 pi, we then found the halfway point, and then like the halfway of the halfway points, the quarter points. So halfway between 2 pi and 4 pi, what will that be? 3 pi, right? So halfway between there, we'll put a little 3 pi. Okay, and then halfway between 2 pi and 3 pi, halfway between 2 pi and 3 pi, or halfway between 2 and 3 is 2.5 or 5 halves, right? 5 pi over 2. And then halfway between 3 pi and 4 pi, well, halfway between 3 and 4 is 3.5 or 7 halves pi, 7 pi over 2. Okay. So sine of 5 pi over 2 will be coterminal. All right, 5 pi over 2 is coterminal to pi over 2, so just sine of 5 pi over 2 is the same thing as sine of pi over 2, so it'll just be 1. So you get a 1 there. Okay. Sine of 3 pi is 0. Sine of 7 pi over 2, it's coterminal to the 3 pi over 2, so it'll be -1. And then sine of 4 pi, that's coterminal to 2 pi, so it's just going to be back up to the 0 again. Whoops, sorry. Okay, so you can just kind of continue the graph there. Like so. And of course, you know, I understand that it keeps going, so I like to put some dotted lines there at the end just to show that it does kind of keep going. Okay, and so there's sine of x. There's sine of x. Questions on any of that? We're all good? All right, so now let's do cosine. Then we'll do the same thing with cosine. We'll do the same thing here with cosine. In fact, I'm going to kind of try and line it up just like I did there. Okay. So let's instead we'll erase sine of x, and now let's do cosine x and graph it. And it's not much different than sine of x. Right? In fact, it looks awfully similar. Awfully similar. What would the domain be of cosine of x? What's the domain going to be here, you think? Okay, all real numbers, yeah, negative infinity to infinity. Okay, and what about the range? What's that going to be? For cosine, what's the range going to be there? Negative 1 to 1, you got it. And we're going to, again, include negative 1 and 1, just like we did before. And the period for this, well, it also repeats. Okay, it also repeats. We're going to say the same thing. It's 0 to 2 pi. Okay, it also repeats every 2 pi. And again, for cosine, we'll go ahead and do 2 full periods. Okay, so let's see here. Let's see, there's 1. There's negative 1. And again, we'll start at 0. We'll go out to about 2 pi there. And I'm going to actually just try and like line things up here, just for comparison's sake. Alright, so I'll also put in pi over 2, and then 3 pi over 2. Alright, so now what's cosine of 0? So here's 0 on the unit circle, right? Cosine is the x-coordinate, so what would the x-coordinate be here? X-coordinate is, no, y-coordinate 0, right? That's on the x-axis, so it's 1. 1, 1, 1. Yeah, that's at 0. Cosine of 0 is 1, so we'll put a point right there. Okay? What about cosine of pi over 2? What's the x-coordinate here? Cosine of pi over 2 is 0. Okay, 0. So now again, just for this first piece here, we'll go ahead and do like the in-betweens. So pi over 6, pi over 4, pi over 3. I'm going to squeeze those in there. What's cosine of pi over 6? Or 3 over 2. So about, 0.8, about what was it? 0.8, 0.86, 0.87, we'll say, 0.87. So, kind of close to 0.9, so I'll say like right there. Okay? And then cosine of pi over 4? Root 2 over 2, which is about 0.7, so a little bit lower. And then cosine of pi over 3? 1/2. So that's easy to graph that. Okay, so you can kind of see. Okay, it's going down, just like that. Okay. And then between pi over 2 and pi, we're going to be in the second quadrant, so cosine will be negative, and of course, our graph of cosine is going to go into the negative, y values there. But let's just go ahead and skip ahead. What is the cosine of pi? What's the x-coordinate here? Negative 1. So cosine pi is negative 1. Okay, so we can kind of like just continue our graph. Cosine of 3 pi over 2? 0. And then cosine of 2 pi? Back here, so it's what? Oh. pi is 1. Okay. So the full period of cosine looks like that. Starts up, hits the 0, goes down, hits the 0, goes back up. Okay. Starts off 0, -1, 0, 1. Like that. Okay. It kind of, I mean, again, for visual purposes, just maybe to help you remember, like what the basic period of a cosine graph looks like. It, kind of is like a C. It looks kind of like a C, right? When you turn the side, it's kind of C-shaped a little bit, right? Whereas the sine graph, right, one full period of sine kind of looks like an S, right? Like a backwards S, I guess, but like an S. Okay. Whereas the one full period of cosine looks like a C. Okay. But of course, once I put in a second full period here, it's going to look like an S again. But at least with one period, it looks like that. So again, if you imagine, right, that's one full period. We're just going to take this thing. It's just going to go and copy, paste it over there between 2 pi, 4 pi as well. So let's go ahead and do that. So be halfway between 2 pi and 4 pi is going to be 3 pi. Okay. Very good. And then halfway between 2 pi and 3 pi, well, it's the 5 pi over 2, right? We have those, I guess. Maybe that's why you're like, you guys don't want to say anything because it's right there. Okay, so we'll just line those same things up. Okay. So the 5 pi over 2, it's coterminal to the pi over 2, right? Just subtract 2 pi from 5 pi over 2, you're back, boom, at pi over 2. So 5 pi over 2, or sorry, cosine of 5 pi over 2 is just like evaluating cosine of pi over 2, so it's going to be 0. 3 pi is coterminal to pi, so cosine of 3 pi is the same thing as cosine of pi, it's going to be -1. And then 7 pi over 2 is back to 0, and then 4 pi is back to the 1. And so we end up with our wave here. Okay, and there it is. And again, it continues, right? Like that. It's going to kind of continue. But there's 2 full periods. 2 full periods. All right, questions on any of that? Questions on any of that? All good? Too easy? Too hard? All right. So then, those are the basic sine and cosine, but now we're going to look at what happens when we start to manipulate those graphs. So for example here, okay, let's take a look at y equals 2 times the sine of x. Okay, y equals 2 times the sine of x. Okay, so we'll make a little table here. Rather than regraphing the entire thing, we'll just make a little table to see what kind of happens. Alright, and first we'll look at y equals sine of x, and then we'll say y equals 2 sine of x. Okay, so just for comparison's sake, we'll take the x values I'm going to put there, right? We'll go ahead and evaluate them for sine of x, and then we'll see what happens when we do twice sine of x. So I'm going to pick the x values, the basic ones that we kind of did up here in the graph. So for example, we started at 0, and then we evaluated pi over 2. Yeah, I know, we evaluated technically pi over 6, pi over 4, pi over 3, but let's just do the pi over 2. Then we evaluated pi, and then 3 pi over 2, and then 2 pi. Okay? This is what you guys are doing today?
Standard form stuff.
Okay, cool, thank you. Thank you. I didn't get through to the...
I haven't done the last one on the last problem on the other one. I did all y to the representation.
Yeah, that's what I'm going to be doing too. So I have to start that today because I have to do slope intercept and point slope sum today or slope intercept today because I was doing the survey. Yeah. Is quiz Friday?
I think so, but then test is next Friday.
Okay.
So then Thanksgiving gets in the way.
Right. Yeah, nope, gotcha. Okay, so sine of x, right? We already know that sine of 0 is 0, right? Sine of pi over 2 we said was 1. Again, back to our graph there. Sine of pi over 2 is 1. Sine of pi, we got 0. Sine of 3 pi over 2 is -1. And then finally, sine of 2 pi, right back to there, it's 0. So we got those 3 things. So then that was sine of x, but then what about 2 sine of x? Well, there's 2 sine of x right there, right? So if x is 0 and y equals sine of 0 was 0, what will be twice sine of that x be then? What's it going to be? Well, it's 2 times 0. So it's just 0. Okay? Sine of pi over 2 is 1, but it'll be 2 times 1, so it'll be 2. Sine of pi is 0, so it'll be 2 times 0, which is just 0. And then sine of 3 pi over 2 is negative 1, so it'll be 2 times negative 1, negative 2. And then 2 times 0 again, 0. So then what's changed? What's changed? Well, in the original sine of x, right, in the original sine of x here, what was the range of sine of x? What was the range of sine of x? Negative 1 to 1, right? Okay, what's the range of 2 sine of x? Negative 2 to 2. All that is a vertical, okay, kind of stretch, a vertical stretch, okay? And so let's go ahead and graph this then on my graph here, and I think I'll be able to fit it. Maybe. Might be kind of too big, but we'll see. So I'll say there's 2 up there, there's negative 2 down there. I'm going to use a different color there. Okay? So 0 is still 0, right? Sine of 0 is still 0. But sine of pi over 2 is no longer 1, it's going to be 2 now, so it's going to be up here. Sine of pi is still 0, so sine of 2 pi. 2 sine of pi is still 0, so it's there. 2 sine of 3 pi over 2 will now be negative 2. And then 2 sine of 2 pi will be 0. And so we're going to go up like that. Like that. Okay. And again, you kind of follow the pattern. Okay, 5 pi over 2, then it'll also be at 2. 3 pi will still be at 0. 7 pi over 2 will multiply by 2 will be negative 2, and then back to 0. So you can even continue through the second period there if you want to. Okay, and so there's the rough sketch. All we did was just change the height, right? Change the height of that sine graph there. There it is. And so that A, this value here that's in front of that sine graph, the value that's in front of the sine graph, all right, we talk about that and we call that the amplitude. The height of the wave there is changing from 1 to 2, so we say the amplitude is changing. Okay? So the amplitude is y equals A times sine of x, okay, or y equals A times cosine of x. Okay, it's that number, that coefficient A, that's in front of the sine of the cosine there, whenever you like run across those problems. Okay, the one thing it's key to remember here is that the amplitude is always, you always describe the amplitude as being positive. Okay. The idea being that amplitude, when you're talking about amplitude, you're talking about the height of the wave, okay? We call these waves, right? Because they kind of like undulate like a wave, right? The height of a wave, right? A height is a measurement, so we always want to talk about it being positive. Yes, you may run across negative A values, okay? And that's true. That will, reflect it over the x-axis, essentially. But again, when we talk about amplitude, when we say, okay, the amplitude of this thing, we never say the amplitude of this wave is negative 2. If it's a negative 2 for your A value, then the amplitude would be 2. You just say 2, okay? So, just keep that in mind, all right? It's always positive when discussing amplitude, okay? All right. And then I have one other behavior I want to talk about there. So any questions thus far? Any questions thus far? Questions thus far? And that's amplitude. All it does is just stretch, okay? The zeros stay the same. Domain stays the same, period stays the same, right? We're still repeating every 2 pi here. But the height changes, the range changes. Okay. look at one more thing here, and that is we're going to look at a horizontal stretch. We talked about vertical stretches, right? That was changed in amplitude. Now we're going to talk about a horizontal stretch, which is a period, change in the period. Okay? And so to affect the period, or the length of the period, okay, it's the b, the number b there in front of the x term. Okay, so sine of bx, cosine of bx. Okay, and the easiest way I can kind of show you how this affects things, easiest way I can show you how to kind of correct with the bx, like how to fix the graph and stuff, is to do something like this. You take your kind of term, your expression in the parentheses there, the bx, and you put it between the traditional kind of period there. So we take that bx and just put it directly right there in a kind of a compound inequality between the traditional 0 and 2 pi. Okay? And this is the same thing is true for cosine as well. Cosine, it works for cosine or for sine. Okay. And then you just solve for x here to get your new period. So to solve for x here, we would divide everything by b, right, to get the x by itself. And so we're left with 2 pi over b. And then 0 divided by b there is still going to be 0. Okay. So that bx, okay, the b there, rather than extending, rather than stretching the period by that amount, right, it actually divides it, it shrinks it by that amount. You know, depending on what it is. The b is like 1/2, it'll make it bigger. A, right, whereas with the a when it was a 2a, it made it taller, right? So then that makes it kind of a straight multiply. But here, the b value there, it's not going to stretch it that much. It'll actually it's going to, contract it that much, maybe you want to say. So let's compare here, for example. Let's compare, for example, sine of 1/2 x, okay, versus just y equals sine of x. Okay, so let's compare these two. Right here, right, our normal kind of y equals sine of x, and then the 1/2 x, which is, so amplitude's still the same, it's still 1, right? But then the period's going to change by a factor of 1/2 there. And again, I'll do a table. This time I'll do a horizontal table, though. Okay, and again, I'll put sine of x, the normal one there, or the traditional one, the usual one, and I'll do 1/2 x underneath that. And again, we'll pick our normal values for x here. So 0, pi over 2, pi, 3 pi over 2, 2 pi. Okay. And again, sine of 0 is still 0, sine of pi over 2 is still 1, sine of pi is still 0, sine of 3 pi over 2 is still -1, sine of 2 pi is still 0. But now when we go to evaluate these other things, my x value here is 0. I'm going to plug that 0 in for x. I'm going to take the 0 and multiply by 1/2. 0 times 1/2 is still 0, so we're going to do sine of 0. And what's the sine of 0? Well, still 0. So you're like, no big deal, Mr. Meyer, where's the change? Well, look at the next one here. Pi over 2. Plug pi over 2 in for x, multiply it by 1/2. What's pi over 2 times 1/2? Pi over 2 times 1/2. What fraction? Pi over 4. Yeah, what's sine of pi over 4? Root 2 over 2, which is approximately 0.7. So, whereas in normal sine, pi over 2, we just evaluated sine of pi over 2, we got 1. Now with sine of 1/2 x, right, sine of 1/2 times pi over 2, it's going to be root 2 over 2, which is actually 0.7. So we were, original sine's already at 1, here it's just at 0.7. Now we plug in pi, all right, plug in pi. Pi times 1/2, pi over 2, right? What's sine of pi over 2? 1. Now we're at the 1 here. 3 pi over 2, well, again, we're going to multiply by 1/2, so it's really 3 pi over 4. What's sine of 3 pi over 4? No, it's still root 2 over 2, or about 0.7. Okay? And then finally, 2 pi. What's the sine of, well, sorry, 2 pi times 1/2 is pi, so the sine of pi is now 1. Okay, so you can, wait a minute, I made a mistake here somewhere. Let me see. This should be sine of pi. What did I do? Oh yeah, that's 1. Okay, my bad. That's 1. This should be 0. Sine of 2 pi. 2 pi times 1/2 is pi. Sine of pi is 0. There we go. Yeah. Sorry. So it is 1 and 0. Okay, so now we graph this real quick. I'm going to graph both here. Okay, and again, I'll put -1 and 1, because our amplitude there is still 1. Okay, I'm going to go out to like 2 pi here, and so there's pi over 2, 3 pi over 2. Okay, so I'll graph sine in green, and I'll do sine of 1/2 x in red. So again, sine of 0 is 0, sine of pi over 2 is 1, sine of pi was 0, sine of 3 pi over 2 is -1, and then sine of 2 pi is 0. Okay. So again, there's sine of x, no surprises there, that's what we've been doing. But now if we look at sine of 1/2 x, which is in red, at 0, it's still 0. But at pi over 2, instead of being 1, pi over 2, it gave us root 2 over 2, right? Because it's pi over 2 times 1/2, and then sine of that pi over 4. So it's 0.7. So pi over 2 is going to be like right, I don't know, like here, we'll say. And then at pi, it's 1, because again, pi times 1/2 is pi over 2. Sine of pi over 2 is 1. So at pi, it's actually a 1. Because at that pi value, we're really evaluating sine of pi over 2, so that's why we get the 1 there. And then at 3 pi over 2, well, it's really 3 pi over 4, which is again 0.7, so roughly the same height there. Ooh. Okay, and then at 2 pi, we multiply that by 1/2 is pi, sine of pi is 0, so we're back to the 0 again. And so it's going to look something like this. Okay, like so. You can imagine, right, that if we extend this out, in fact, we would get the full period there. Okay. Like so. How are we supposed to go about doing this? Like, how do we come up with those like values and things, right? Because like the sine, it was pretty easy. We're familiar with that. But then when it comes to this like stuff where we throw in the b and all that, how are we supposed to come up with like the points? How do we know which points to use, right? Because you know we could just as easily have tried to do some other points here and run into some trouble. Well, the thing you want to shoot for here when you're setting up your x-axis, okay? To set up your x-axis here, okay? When setting up your x-axis, or when labeling the x-axis, okay, you're going to want to label the start and stop point of the period Okay. Find the halfway points. And then find the quarter points, the 2 quarter points. Okay, of that interval. I guess we'll add that to step 2 there as well. Okay, so that's kind of what you want to do there. When setting up the x-axis, you're going to label the start and stop of the period. All right, so again, sine or cosine, that's 0 to 2 pi. In this case, the period was 0 to 4 pi, right? Because the way we solved it there, we had 0 less than or equal to 1/2 x less than or equal to 2 pi. Oops, less than 2 pi, I guess we're saying. Okay, multiply both sides by 2, you get 0 less than or equal to x less than 4 pi. And so there's your period right there. 0 to 4 pi is when this thing repeated. And so you graph from 0 to 4 pi, find the halfway point, 2 pi, and then find the quarter points of the interval, pi and 3 pi in this case. Okay, and then evaluate those, and that'll get you what you need for the graph. All right. So, all right. That is that. And I'll give you guys some problems here to practice with that from the homework. Okay? So let me get you the assignment here.